Okay, example 1. Suppose the mean weight of adult men is 82 kilograms with a standard deviation of 16 kilograms. Okay, find what percentage of men weigh more than 220 pounds. And they also let us know that there is approximately 2.2 kilogram or 2.2 pounds in a kilogram. Okay, so really what we're trying to do here is to find the probability that x is greater than 220 pounds. Okay, but we need to first convert the pounds into kilograms. Okay, it tells us that there is 220 pounds. It also says that 2.2 pounds are in a kilogram. Okay, so if we want to convert this into kilograms, you can do some unit analysis here if you like. Okay, this is 1 over 2.2 kilograms per pound. Okay, so here I've got 1 over 2.2. That will cancel out the pounds. Basically what I'm doing is just taking the 220 pounds and dividing it by 2.2, and I will get that 220 pounds converts into 100 kilograms. Okay, so now that everything's in kilograms, I can actually do this question. Okay, it's telling me, here's my normal curve, it's telling me that the average, the middle, is 82, and I'm trying to find what the probability of a man weighing more than 100 kilograms, which is the same thing as 220 pounds. Okay, so here these are our x values, and what we'd like to do is convert these into z values so that we can use our standard normal table. Okay, so we know the middle will convert into 0, and we can use this formula to convert x's into z's. Okay, so the x value that we are trying to convert is 100. The mean or the middle is 82. And the standard deviation, we are told, was 16 kilograms. Okay, if you calculate this out with your calculator, you get the value 1.125. Okay, so why don't we just round this then to 1.13, just because our Z table doesn't have thousands. It only goes up to hundreds. Okay, so what we're trying to do then is, well, we've converted this value, this x value, into a z value of 1.13. And what we'd like to do then is to find the shaded probability here. Okay, so what we can do is we can go to our Z table. Notice here that this is a cumulative Z table. It is the less than or equal to it's always giving you. It's actually giving you the less than or equal to sign. And what we're really interested in is the greater than sign. So when we go to our Z table, we will have to get that value and then find its complement so that we can find this greater than value. Okay, how we do that is we're looking for the value 1.13. Go to the row listed as 1.1 and where it corresponds with 0.03 for a total of 1.13, and you'll see the value here, 0.8708. Okay, let me just show that to you on the actual sheet. Sorry, that's the wrong form. Here's our Z tables here. Okay, if we go to the positive side, remember we were looking for the value 1.1, so in this row, and where it matches up with 0.03, and notice here the same value that I got. This is the 0.8708. Okay, so here's the 0.8708, but remember this is the cumulative distribution. This is the less than or equal to. What I'm really looking for here is the greater than sign. Okay, so here I'm looking for the probability of, I'm looking for the probability that Z is greater than 1.13, which I know that I can calculate by finding the complement of the cumulative value. So this in the end ends up being 1 minus 0.8708, and you can find this probability then to be 0.1292. Okay, so there's the final answer. There's the probability. Of course, I can do this in Minitab as well. Okay, there's a few ways to do it in Minitab. Okay, if you go into Minitab and you are calculating a probability distribution, so you go to the Calc tab, probability distribution, normal. Okay, notice here that Minitab can only do two signs, the probability density, this is the equal to sign, or the cumulative probability, this is the less than or equal to sign. Okay, one way that we can do this is by putting in our Z value that we found. Remember that it was 1.13. Okay, so if I click here, the cumulative probability, this will give me the less than or equal to value. Remember, we found this in our Z table to be 0.8708. Let's see what Minitab gives us. Okay, so here we get 0.807, and this would round up to 8. Okay, so that's one way that you can do this in Minitab. The other way is to not convert it into a standard normal, to not convert it into a Z, but let Minitab do that for you. Okay, you can do this by having the cumulative probability and telling Minitab that the mean, or the middle, of the graph was 82. The standard deviation we were told was 16, and then the value that we're looking for here is to be, in this case, less than 100, and we'll have to find the complement then to finish off the question. If you use Minitab this way, we will also get a very similar value here of 0.697. This isn't the same value as the 0.8708, but that's only because remember that we actually rounded our value. Our Z value was actually 1.125, and we rounded it to 1.13. Okay, so here, if you don't round, this is actually a more accurate value, but they are very similar to each other. Let's continue on with question B. Okay, among the 100 randomly selected men, how many do you expect will weigh more than 220 pounds? Okay, so this is a kind of a complicated question if you don't remember kind of some history from Stats 213. Okay, I'm going to start here by noticing the sample size was 100 men, and we're trying to find how much we expect will weigh more than 220 pounds, which of course, remember, converts to 100 kilograms. Okay, so I'm going to think about the situation here. There's two options. Either a man weighs less than 220 pounds, which is 100 kilograms, or the person weighs more than 100 kilograms. Okay, there's two options there. The probability that somebody does weigh more than 100 kilograms, we just went over actually. We just found that probability that someone weighs more than 100 kilograms. Okay, if you don't remember what this is, just go to part A and you'll find there that the probability that we found was 0.1292. Okay, so that's the probability that somebody that a selected adult man will weigh more than 100 kilograms. And now what we're looking for is the expected value out of 100. Okay, so actually what this is X actually is the number of men out of 100 who weigh more than 220 pounds, which is the same thing as 100 kilograms. Okay, so if this is the case, then X is actually a binomial situation where N is 100 and the probability of success is 0.1292. Okay, and really what we're looking for here then is the expected value. Okay, the expected value, of course, for a binomial, you'll remember from Stats 217, is N times P. This is 100, and N was 100 people, and P, the probability was 0.1292. Okay, 100 multiplied by that would just be 12.92. Okay, so let's just sum this up here. We expect 12.92 men of 100 to weigh more than 100 kilograms. Okay, let's go on here. Part C. If 5% of adult men weigh less than how many kilograms? Okay, so we need to find that weight. Okay, again, you can start this by drawing a picture, might help. Okay, so something that's important here is the value, or is the word less than. That is indicated by this sign here, the less than sign. Okay, so really what we're saying here is, here's my graph again. This value here is what we're looking for. We're not sure what it is, but this percentage is 5%. Remember, of course, the middle was 82 kilograms. Okay, so the middle, that's mu, was 82 kilograms. The standard deviation was 16 kilograms. Okay, so we're trying to find what this value here is. Okay, so how do we do this? Okay, so here we've got this value, this cumulative value, remember this is the less than or equal to sign, is 5%. What we need to do first is to go to our Z table. On the inside, we've got the probabilities here. Okay, so we need to find this cumulative probability of 0.05, this 5% cumulative probability. You will find it in the row -1.6 and somewhere in between 0.04 and 0.05. So the number that's in between those two values is the number 0.045. Let me just show you exactly what that looks like. Okay, so what we're trying to do is find the value 0.05 in this graph. Look, here is the number 0.0505, and here is the number 0.0495. So 0.05 is somewhere in between these values. Notice that it is in the row -1.6, and like I said, in between the value 0.04 and the value 0.05. Okay, so we found this corresponding Z value. Okay, let me just redraw this graph. Okay, here is 5%. The middle is 82. We're trying to find this value. These are the X's. But if they were converted into Zs, we know the middle of a Z, a standard normal distribution, always goes to the value 0. And we also found that the corresponding Z value for this particular value that we're looking for, is of course -1.645. Okay, so we have the Z value. What we need to do now is convert this Z value into this unknown value that we're looking for. Again, we can use this formula, Z equals X, subtract mu divided by the standard deviation, but this time the thing that we're looking for is actually the X value. We have that the z value is negative 1.645. We're trying to find this unknown x value here by subtracting the middle, which is 82, and dividing by the standard deviation, which is 16. Okay, so you can rearrange this formula. Basically what you end up getting is negative 1.645 multiplied by 16, add 82, and this will give you your unknown x value, which is now known to be 55.68. Okay, so maybe just remind yourself what it is that we just accomplished. 5% of adult men weigh less than 56 kilograms. I guess I should round up. Okay, so let me get rid of that. 56 kilograms. Okay, I hope that worked out for you. If you need to review this, watch and rewind, go ahead and do so.